All right, for the last video of this week, we're going to talk about a quicker way to find the derivative of a function. And that shortcut is actually called the power rule. And this is going to be really helpful when you get to calculus to be able to find the derivative quickly. Based on what you did in the Google form for the previous video, these are the answers you should have found. And I just want to kind of go through these with you. So for number 1, we had the original function f of x is 2x squared plus 1. The derivative was just 4x. Second function you had f of x is 3x minus 5x squared. And the derivative ended up being 3 minus 10x. And I'm going to pick just a few of these to look at, sorry about that, right now, and then we'll go back and look at a few of the others. So for number 3, you had f of x equals 9 minus 1/2 x squared. The derivative was just negative x. For number 5, the original function was f of x equals x cubed minus 1. Derivative is just 3x squared. And for number 6, not number 6 yet. Okay, for those 4. Now I want to show you a couple more that might help kind of solidify what's actually happening here. So here's a few more. Let's just look at some of maybe a few to start with here. So if we saw a function like f of x equals 5 or f of x equals negative 57, notice the derivative on both of those is 0. It's an interesting thing, right? We have the derivative of a constant function was just 0. Let's look at just linear functions for a moment. So f of x equals 2x plus 1. That's a linear function. Here's another linear function. Here's another linear function. And look at the derivatives. So what do you notice about the derivatives of all of these linear functions? Okay, so for those linear functions, the derivative 2 is actually what the slope of that function was, which we kind of saw in one of the previous videos. Look, the slope is negative 3, the derivative is negative 3. The slope is negative 2, derivative is negative 2, and so on. Interesting, okay. Let's take a look at some of maybe the higher powered ones. So our quadratics. So here's some quadratics, right? Now look at these derivatives. They're a little more interesting. So the slope of f of x equals x squared minus 4x ends up being 2x minus 4. Now we can kind of see how negative 4 is just sort of where the slope would be if this were a linear function. But how did we take that x squared and make it 2x? Okay, how did we take, we get the kind of, this is our slope if it were just a linear function, but notice we have this negative 2x squared that becomes negative 4x. There's no linear part to this, right? There's just the quadratic part, and it goes from negative 3x squared to negative 6x. So what's really going on here is that, let's see, the derivatives, let's make ourselves a little note here. Derivative. All right, so the derivative of a constant function, that's what I have highlighted in pink, is always 0. The derivative of a linear function, okay, so that's like mx plus b, right, is always whatever your slope would be. So if you have something like mx, the derivative is just m. So it gets a little more interesting the higher the power goes. So like for our quadratic here, okay, we go from an x squared to a 2x. We go from a negative 2x squared to a negative 4x. We go from a negative 3x squared to a negative 6x. Do you see what's happening? Look, we take whatever the power was here, which is 2, okay? And think of you have this imaginary 1 out in front of your x squared. Okay, so think of taking that 2 and multiplying it by 1. That gives us 2. Okay, interesting. 2 times negative 2, that would give us our negative 4. 2 times negative 3, that would give us our negative 6. Now, what's more interesting is, what's the actual power on each of those derivatives? our power of x is just 1. So what we did, let's kind of look at one that's not one that's already done for us. Okay, so let's say I had 14x squared. What we're really doing here, guys, is we're saying, here, take that power that's on x, multiply it by 14. So 2 times 14, well, that's 28. And then whatever your power on x was, well, it went from 2 to 1. So just reduce it by 1, and that would be the derivative. So let's look at this in this last part that we haven't actually talked about yet. 5x cubed plus 2x squared minus 3x minus 4. Look at the derivative. 15x squared. Well, that's because we took 3 times 5 to get 15, and then took this from being a cubic, and it reduced to be a quadratic. Here we have our power of 2 times 2 to get 4. Took this from a quadratic and reduced it to a linear term. Here we have, think of that, that's a 1 as a power here, right? So we're really saying 1 times negative 3 gives us negative 3. And when you reduce that down to the next lowest power, that just becomes x to the 0 power, which is just 1. And then our negative 4 is a constant term, and we know those always end up being 0. So this is a much faster way, this power rule, of finding the derivatives. Now, there's ways that you can do this with radical functions and with your rational functions like you see below. Those can be a little tricky, and you might be able to figure those out just based on the experience that you've had so far. But they go back into talking about, what is the power on a quadratic, or not a quadratic, a radical function. What is the power of x on a rational function? And still using this power rule. That's a little bit more than what we're going to get into. And, I'll show you what I mean. We could rewrite f of x as x to the 1/2 power. And then you could still go through that same process that we just talked about. Multiply the power times what's in front. So that would be 1/2 x. And then reduce this power by 1. Okay, well, that makes that negative 1/2 as a power. Now, without going into a lot of explanation here, that negative 1/2 power looks like this, which then becomes that, we've seen that that's been happening in our previous experience. And then with with f of x equals 1 over x, once again, you can think of that as we can think of that as x to the negative 1 power. And then the same thing that we did before, we take that negative 1, multiply it by the number out in front, and reduce whatever the power was by 1. So negative 1 reduced by 1 is negative 2, which becomes negative 1 times 1 over x squared, which is that negative 1 over x squared that we've been seeing as our answer in those problems. Now, here's the thing. I'm really not concerned with you guys having that right now, because that's pretty tricky, and we aren't going to have a lot of time to talk about that together in class and kind of work through that. Next year, you can anticipate that your calculus teacher will have to spend some time talking about, how do you work around those? Is there an even shorter way of getting to those derivatives? But for now, I need you to be able to do this kind of stuff. So take a moment, pause the video, see if you can find the derivative of this function right here. Come back, check your answer, and then we'll maybe do 1 or 2 more, and then you'll have some time to practice. So hopefully this is what you found. Again, we take the 3 times the negative 2 to get negative 6, and then reduce the power of x by 1 to get x squared. 2 times negative 7 gives us negative 14. Reduce the power of x to be the power of 1. And then that's just a 1 there. So 6 times 1 is 6, reduce the power of x to be 0, and then our constant term always has a derivative of 0. Okay, let's try 1 or 2 more, and then I'll have you practice. All right, take just a minute, try these 2 problems. Once again, pause the video, see if you can do them, come back and check your answers. Okay, so you should have the 2 answers that you see there, and once again, this is just a shortcut. Imagine if we had to use that process of finding the limit with these problems. I mean, that would be a nightmare. We'd have to use Pascal's triangle, and then you'd have a huge amount of terms between all of these. Once you add in the x plus h, it gets to be a real, very long process. And it's not useful to go through that process when you have to use this the idea of finding a derivative to do some other things that are going to be really important in calculus. So hopefully this shortcut helps you out a little bit. And this last little Google Classroom assignment should be pretty quick. I'm going to throw a couple of challenge problems on there that you can try if you think you've got the process for finding the derivative of your rational and radical functions. Otherwise, just do the required ones, and that'll be it. It's the last video for the week, last lesson for the year. I gotta say, I'm kind of sad. I wish we could have ended the year a little bit differently. None of us really saw this as being the way the year would end when we started out. And I just want you to know I'm very proud of all of you. Seniors, I'm just so sorry that I'm not going to get to give you a hug on your last day. I miss all of you guys, every one of you. I hope you have a fantastic summer, and I really hope to see you in the halls of Gahanna Lincoln next fall. Have a great summer, guys.